Here we go. All right, so when I'm solving a fractional equation, the whole idea is to get one fraction on the left. So I'm trying to turn all this into one fraction, and then to have one fraction on the right. And I already have one fraction on the right, so all I need to do is get a common denominator on the left-hand side and add those two things together. Okay, so easier said than done. Not that it's hard, it's just not our favorite thing to do, maybe. So if you look at the denominators, they're not anything in common, right? So I'm going to have to, basically what I can always do to get a common denominator is the x plus 4 could use the x minus 3 with it, right? But in order to keep an equal fraction, if I do it to the bottom, I got to do it to the top. And the x plus 3 over here, it needs an x plus 4 to have a common denominator. So if I do it to the bottom, I got to do it to the top. And all of this equals this right-hand side. And right now, I'm not even worried about the right-hand side. I'm just kind of, leaving it alone. Because it's at least a fraction, right? Okay. All right, so now if I go to clean up the left-hand side, I can put these two fractions together. They're going to have a common denominator of x plus 4, x minus 3. It doesn't matter which one of the factors I write first. I could just as easily have written x minus 3 times x plus 4 there. But I got to clean up what's on the numerator on this left-hand side. 3x times x is 3x squared. Yuck. 3x times negative 3 is negative 9x. Over here, 4x times x squared is 4x squared. And 4x times 4 is 16x, right? And again, I'm not doing anything with the right-hand side. I'm just kind of keeping up with it. Yeah, we need to do that. I was just taking a minute to see what his approach was to something, because this is a very different approach of what he does here than any other book I've ever seen. Okay, so yeah, we do need to add like terms up here in this numerator. 3x squared plus 4x squared is 7x squared, right? And then you have a minus 9x and a plus 16x, so that's what? 7x, very good, 7x. All over x plus 4. X minus 3. Now, normally what would happen here is we would cross multiply, but this is a weird book. Okay? I want you to think about this on the denominator on the right side. How would you factor x squared plus x minus 12? Let's just come off to the side and do it. I'm trying to find two things that multiply to give me minus 12. And then at the same time, they got to add to that invisible 1. That's the coefficient of the x in the middle that I wrote in just now with that big ugly mark. How would that factor?
4 and negative 3.
Okay. 4 and negative 3. Huh. Isn't that x plus 4? X minus 3, right? Isn't that what that is? Doesn't it match the other side? Okay. I'm going to pause. And in the book, almost every single problem is this way, except what gets me is the one they picked for the test is not this way, and yet almost every other problem in this problem set is this way. Couldn't I multiply both sides by this right here and clear out the fraction? Okay, let's do this. Well, exactly that's what I was checking on a minute ago, because I'm like, is he really doing that? Because I've never seen a book do that. If I multiply both sides by x plus 4 times x minus 3, that would clear out those fractions, right? Okay. If I do that, and again, I had to kind of cram it in on the first fraction, this cancels out this, right? And this cancels out this. And what I end up with is 7x squared plus 7x is equal to 84. I didn't even have to cross multiply here because he has set up so many of the problems this way. It's kind of crazy. Never seen a book do this before.
I wonder how he even comes up with that.
I don't know. He's considered to be a very rigorous, advanced kind of guy. That's why I'm not quite sure why he does what he does. Sometimes I'm looking at it going, but, why am I moving the 84 to the other side?
To get
I want all the terms on one side, because in order to solve a quadratic equation, which is what I have, remember a quadratic equation is just an equation with a square on it. In order to solve it, I got to get all the terms on one side and 0 on the other side. Now, inwardly, I wanted to groan, because I'm thinking that's going to be hard to factor. But is it? I can factor it. I don't want to use quadratic formula if I have to, because I don't like that sucker any more than y'all do, okay? Guess what? 7 goes into 84 evenly. Isn't it in every term? Guess what? There's a GCF. Hallelujah. Do a happy dance. If I factor the 7 out, that would be 7x squared take out 7 would be x squared. 7x take out 7 would just be x. And 7 goes into negative 84. Y'all might want to check the math on this, because I think it's 12, but I'm just going, that does not. Yes, it's 12. Hallelujah. Because I thought we were going to have an icky mess here to factor, but this one actually, it's nice when a GCF comes out, because really, doesn't that mean I can work this problem so much easier now? Because I can say all I really need to do is factor this part, x squared plus x minus 12. I'm trying to say what two things multiply to give me negative 12, and at the same time add up to that 1, that coefficient of that middle term. Yeah, 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. And again, if you're still struggling with how I'm coming up with those numbers, you're kind of thinking what multiplies to give me either 12 or multiplies to give me negative 12. You can think 4 times 3 is 12. How would I get a 1 out of a 4 and a 3? I would subtract the 3 from the 4. Let's check those numbers out again. Is 4 times negative 3 negative 12? Hey, yeah, that worked out, didn't it? Okay. So if I realize that's what I got to do here, it's just 7 times this part that I circled in green factors into x. That's a positive 4, so it's at plus 4, and then an x minus a 3 is equal to 0. And now, if you got a bunch of stuff and it multiplies equal to 0, then that means one of the factors in it has to be 0, because the only way to get 0 is to have something, a 0 in there somewhere. So do you remember that what you do is you set each factor equal to 0? 7 equal to 0 doesn't make sense, so no, we're not going to do that, but we can say x plus 4 is equal to 0. X minus 3 is equal to 0. We subtract 4 from each side, and we get x equal negative 4 is one answer. And another answer is, add 3 to both sides, we get x equal 3. But we're not done yet. Because there is the possibility that I might find an answer here that doesn't work. This problem was originally, let me go back, let's see, our two answers, I'm going to write them down that we're getting are x equal negative 4, x equal 3. I'm going to have to go to another slide because I need to go back and look. The original equation for this, I believe, if I'm not...
3x over x plus 4,
Uh-huh.
and then plus 4x over x minus 3 equal to 84 over x squared plus x minus 12.
Okay, so here's my list of answers, negative 4 and 3. I'm all happy. I got two answers. Guess what? Neither one of them is going to work. Aren't you happy? Yes. If I took that negative 4 here and I tried plugging it in, like even on this fraction, we don't even need to look at the whole thing. If I put it in here, isn't negative 4 plus 4 going to give me 0 on the bottom? I have to throw that answer out because I cannot divide by 0. The earth opens and swallows us and we disappear if we divide by 0. I can't use that one. When I get an answer and it doesn't work, I call that an extraneous solution. It's an answer I got because of just some of the stuff we did to work the problem, getting the common denominator and multiplying in, both sides by something with a variable, introduced something that wouldn't work. What about the 3? Where was it going to go wonky? Look right here. If I were to plug in 3 in this equation, it doesn't matter on all the other ones, but even just on this one, if I were to put a 3 in for x, wouldn't I have 4, wouldn't I have whatever I have on the top, what am I going to have on the bottom? 3 minus 3 is 0. So that one won't work. They're both extraneous solutions, therefore this equation has no solutions. And I know y'all are excited about all that work for that.